So in this video we will talk about the geometrical interpretation of differentiation. Let's say if we are given some graph, then if we are given some graph like this, let's say this is the graph of function sin x. This is y-axis, this is x-axis, this is y is equal to sin x. Now if I have to find the slope of tangent drawn at any point on this graph, let's say this is the tangent drawn on this graph at this point, which is, let's say, some x naught, and this height be some y naught. Then if we have to find the slope of this tangent and we are given the graph as y is equal to sin x or y is equal to some other fx, then we must know that if let's understand it in a more detailed manner. Let's take another graph, like say this is one more graph, right? And if I have to find, let's say if we are given a secant, this is some point x1, y1, this is some another point x2, y2, right? So this is a secant. If I have to find the slope of this secant, then the slope will be this, where tan theta can easily be found as y2 minus y1, which is this height, y2 minus y1 by x2 minus x1, which is the base. So this is perpendicular and this is base, right? So base is x2 minus x1. So tan theta we found quite easily. But this is the slope of the secant. If I have to find the slope of tangent drawn at this point, let's say this point is A, right? If I have to find the slope of tangent drawn at this point, then what I'll do is I'll try to move this line about this point A, such that right now x2 y2 point is here. If I rotate this line about this point x1 y1, that is A, then this line will become kind of this. x2 y2 point will be here. Next, let's say if I have to move it more, then where will it go? After, if I keep on moving this, line to this side about this point, then finally I will find that this line has almost became a tangent. Like this line will become just a tangent to this graph. When this point x2 y2 converges to point x1 y1, then this secant converges to become a tangent, right? So if I write this y2 minus y1 as delta y and this x2 minus x1 as delta x, then I can easily see that as soon as this x2 minus x1 drops down to almost 0, y2 minus y1 drops down to almost 0, that is, they become very less, then I can easily see that tan theta will become, if dy, this delta y and delta x tends to be 0, then I can write them as dy, which is very small change in y, by dx, which is very small change in x. So I think I can easily tell you, or you must have understood that as soon as this x2 tends to reach this point x1, the secant gets converted, whose slope is this, secant gets converted to tangent. So I can easily say that the slope of tangent drawn at any graph can be easily found using this differentiation of the function of graph. Okay, now in next lecture we will be dealing with maxima minima, which is also based on this geometrical interpretation or slope of tangent that we can find with the help of differentiation.